His name is Dr. Sailesh, sir, who has done a PhD in computer science and currently serving as a professor with Rai University, Ahmedabad. He has more than 22 years of experience in academics, industry, and corporate training, out of which 18 years are in core academics. He has excelled in corporate training, delivered expert talk in various AICT sponsored STPs, FDPs, reputed universities, government organized workshop. His skills and expertise are in big data, applied artificial intelligence, deep learning, and machine learning. Today, he's going to talk about big data analytics for smart cities and smart villages. Introduction to big data. So he has also given a session in our elementary FDP, which was really very good. And I hope today also he is going to deliver a very good session, and every participant will enjoy a lot. Up to you, sir. Thank you.
Thank you very much, sir, and thank you for inviting me again. And I really love to be a part of this FTP where we have a lot of interactive audience, and definitely the management and the organization of the FTP is excellent.
Thank you, sir.
So, with these words, I would just like to share my screen. Should we wait for other people to join, or can we start?
Yeah, I will. I think they will eventually join.
Okay,
Yes, we can start, sir.
fine. I hope the screen is visible.
Yes, sir.
Fine. Yeah. So today I'll be rather giving my views on this topic called big data analytics for smart cities and smart villages. Actually, this is one of my favorite topics of smart cities and smart villages, and I like to combine it with whatever technology we are going for. The reason being that this is going to be the eventuality where India is going to be categorized into two compartments only. One is called smart cities, and second is called smart villages. One of my books also with Bentham Science is on AI for smart cities and smart villages, and second book with IGI Global, which is currently both are in publication, is on data analytics and visualization, big data analytics and visualization for uh, wellness solutions. That means it is related to healthcare. So this has been my favorite topic where we have been focusing upon smart cities and smart villages and what are the necessities and how people can benefit from the softwares or tools that are available for this particular topic. So first of all, I'd just like to give a small introduction about what is big data. I hope you are clear about it, but just I thought I would start with that introduction part and then I'll go on to the actual topic of the use cases and where it can be used in smart cities and smart villages and how it is relevant to the research domain also. So, lot of data is there with us. Archive data is there, internal documents are there, multimedia files, operational and analytical database. So we are flooded with lot of such data with us. But this data, is it translating into something fruitful for us? There are some questions regarding that, right? See, when I talk about lot of, I mean, some applications, I would directly tell you about big data that your spending habits, your eating habits, everything is being analyzed, right? So whenever you are going to a restaurant, you are eating a food, then in the future it will happen that you don't have to order food, right? Everything, all the analysis would be done and you would be given the menu uh, which you can select from, wherein all the items that you like would be preferred. That is, suppose if I say that I prefer Punjabi food, then whenever I go to the restaurant, immediately that restaurant will identify that okay, this person has come who is liking Punjabi food, so the Punjabi menu would be highlighted. If I want to change it, I can change it, but then that would be highlighted. If in the same family my daughter likes Chinese food, then for her Chinese food recommendation would come. So all this is based on a lot of data analytics. Of course, AI, IoT definitely are there in the background serving in various applications that we are going to talk about. but somewhere the big data is being analyzed and a visualization is being given or some decision is being taken on the basis of which you are getting the output that you require. So lot of such changes will come about in the future, right? We would not be having even like suppose if I say that my facial expressions are also being studied and are being noted down, and if suppose I'm buying something, maybe my image may be captured on the app and it may actually uh, give some kind of feedback or analysis or based on which the vendor can either decrease the rate or increase the rate depending upon my requirement. So there can be lot of such applications which we are looking at from big data. But here we are flooded with public web sources, that is we have a lot of information of data from private or government sources which is available on the web. If I just talk about Rashtriya Raksha University, then on that portal also a lot of information will be there. Rai University portal, a lot of information will be there. So all this information is being consumed, is being distributed, is being downloaded. So all this is forming a part of data, right? Sensor data. Now sensors are very much prevalent in most of the applications that we go for. I would just like to share an example here. I would not directly go through the slides only. I will be sharing some live examples here. I was invited as an expert on a panel at Stanley College of Engineering for Women. They had a student forum and they conducted it somewhere in September first week, Sunday. They had an event where they were talking about intelligent systems in smart farming. So they had invited me as a panel expert. Along with me, there were few other people. One was actually a madam who was doing her postdoc from UK. She was working on smart farming. Second was an IBM scientist, actually who was originally from Bihar and he is working with IBM. So we had one or two more panelists who were experts in their field. But when we were discussing it, we were allowed to talk about 5 minutes on that particular topic, give our views on that, and then there was a question answer session where a panel discussion followed. So during one of the discussions, actually, that IBM scientist, I would just reflect upon that aspect only. He said that during lockdown, he was in Bihar, he was in a village in Bihar, which is his village, and there lot of barren lands were there where nothing was being cultivated. मतलब कुछ वहाँ पे उगता ही नहीं था. It was just barren land. It was farmers were not happy with the kind of land that they were having. But they had no other choice. So when he was there during the lockdown, at that time he was given an assignment by IBM that you do something over there with the help of our systems. So they used IBM technology, which used sensors, big data, AI, all three combined, and then they actually implemented it using a cloud there. And to the surprise, actually, it was found that the soil was tested through the sensors and soil testing sensors. Then it was identified that this particular area is good for one particular type of crop, and that crop was seeds were laid down, and within a few months they gave good productivity, and all the things were automated because in the farmer actually laborers were not there. So only the farmer was there and the scientist was there. So they used technology. They used technology to good effect using AI, machine learning, robotics, everything, and then they made that particular land productive enough. And per acre, it gave a profit of 80,000 rupees to the farmer. So what I mean to say is that this was all being visualized. The data was being analyzed, managed, not only by the scientist over there, but also it was on the cloud and it was being monitored by IBM employees who were experts in that agricultural domain. So what I mean to say here is that it's a big achievement as far as big data analytics and visualization is concerned because it can integrate with any technology and it can give you best results. Social media data. After sensor data, probably the most prevalent data that is there is social media data. If I give you an example, that morning itself on WhatsApp, I mean, we have an habit, it's not a good habit, but anyway, as soon as we get up, before brushing, actually, most of us have a habit where we actually take our mobile in our hand and just check our WhatsApp or social media, LinkedIn, etc., just to check whether any important messages are there or not. Now, there are n number of groups on WhatsApp. You might be part of many such groups. On an approximately, if you say that there are at least per group, there are at least 20 to 25 messages of good morning along with visuals, images, or even videos sometimes. All this is creating data. So the previous data that we were handling was basically called structured data, where we had data into tables, rows and columns, right? Now we are dealing with semi-structured and unstructured data also through social media. Any video you are actually passing on through somebody, that is unstructured data, right? So we are dealing with a lot of such social media data, and that also needs to be analyzed because that gives an insight into the person's mentality as such, and how that person's behavior can be uh, judged from that. That also is a very good example of data analytics. So this is what we are looking about here: machine log data. Now there are many machines being used by people on a day-to-day basis in companies elsewhere also, including laptops, systems, etc. This data from machine level, like activity on the server, that also can actually lead to a lot of data. Machine log is an important source of data. So a lot of data is available with us, generated within this. If I try to categorize the data into separate forms, then one is social network data. That is a very huge amount of data. That if suppose somebody says that without water we can survive for a few days, but without internet, we cannot survive. Without mobile, we cannot survive. So this is the true fact of most of the young generation who are actually addicted to mobiles in a way. There was a in Bangalore, there was a de-addiction camp, and one of the doctors in Gujarat also, I have come to know that one of the doctors is working on this de-addiction camp where people who are addicted to mobiles are slowly uh, finding themselves retracting from the mobile syndrome, and they are slowly coming back to normal times. So these de-addiction centers will also be in the future. Uh, there may be many such centers coming up in the near future, and they may also again generate data. So again, data is at the center everywhere. Financial data. Financial data is a very important data, and any bank, financial institution, customer, all these people are generating this data. Multimedia related data. Now you are seeing that with the help of, I mean, due to the lockdown, many private players have benefited from this, like Amazon Prime, Netflix. There are a lot of such OTT series which are coming up and people are viewing that. So that is leading to a lot of multimedia related data. Mobile apps, we normally use apps just like we are using normal spoon for eating. In the same way, we are using mobile app data. It's being generated Uber, Ola, if we are going for through a cab service. Otherwise, there are many such apps which we are using our day-to-day life. So, how are we dealing with that data? That's also important challenge. So, lot of such data is being generated. Data from ERP system and IoT, Internet of Things. So these are all creating a lot of data which is in abundance. Earlier, when I was studying, I was a part of my bachelor's or master's degree. At that time, probably we were looking at very static amount of data. I mean, for banking, we were going to the branch and dealing with the branch of the bank for doing any transaction. Now everything is on mobile. So lot of security features, lot of apps, lot of usage of uh, online location sharing, data sharing. All this is possible, and this is creating a lot of data on the internet and overall also. So big data as such, it's very difficult to define it, but big data is a data whose scale, diversity and complexity requires a new architecture. It cannot be done with the old architecture of rows and columns. And there are a lot of techniques which may be required for that, algorithms and analytics to manage Hadoop, map, reduce. All this is normally being used for big data related analytics. And we want to extract some hidden knowledge from it. Now, there is a always this I've included particularly because there are some terms which are always um confusing. So I just wanted to clear off what is business analytics, what is business intelligence, that is called BI, what is big data, and what is data mining. So these four are totally different, even though they may overlap at sometimes, but then their nature wise they are quite different from each other. So when we are talking about business analytics, uh, they are tools to explore past data. That means whatever data has already been recorded, past data, past 5 years data, suppose, to gain insight into what are the future business decisions that you can make. So that is called business analytics. Business intelligence is our tools and techniques to turn data into meaningful information. So again, we have a lot of data, but we are not getting meaningful information from it. So BI is the right tool for doing that. Big data is where data sets that are so large or complex that traditional data processing applications are inadequate. That means you will not be able to process the data because data are of different types. Data sets are too large or too complex, or there may be different types of data. Like I told you, unstructured, structured, semi-structured. So dealing with all this is a big challenge. So that's why we need big data. Data mining is where we have tools for discovering patterns in large scale data sets. Suppose if I'm looking at a mall, right? If they want to actually have some kind of a scheme being decided for a sale, etc., they may use association rule mining. Clustering they may use they want when they want to group a particular similar kind of characteristic related people, right? Then you may have classification where you are trying to classify according to some basic rules. So all these are data mining techniques which are being used. There are many tools which are available for using data mining also. So these four are the different topics, yet they may overlap at different stages. Now, why do we need support for decision making? First thing is that it's uncertain economics. Now, last 2 years have proved, during the COVID, it has been proved that it's really uncertain. A lot of businesses have really shut down. A lot of businesses which were dependent upon physical, uh, that is, say, offline related activity, that have been affected the most. Small people who are daily wages people, they have been affected in a very drastic manner. So some support is required for decision making which can reach to each and every person, whether rich or poor, whether businessman or job creating person or job giving person or employee. For all this particular economics has been very uncertain. So you need some kind of decision making support. Just recently, it was there in the news channels that India has reported pre-COVID levels of uh, growth as far as the business is concerned. So that's a very good achievement, and if this continues, then probably we'll be much more self-sufficient in all ways because the entire business economics has changed. Now Indians are more concerned with India-related products rather than foreign-related products. So if you do an analysis, actually, I was just working on a project in between for a research paper where we were working upon the effect of COVID on the spending behavior and use of technology on that spending behavior. So we found out that most of the young people who were actually going for branded products earlier, foreign branded products, they have slowly turned their preferences towards Indian products. So this is a result of analytics that we have been able to come to that conclusion. So a lot of changes are coming back in the parameters that we have laid down, and slowly Indian products are being more preferred compared to foreign products. There's a huge global competition. Now, if you want to meet the global competition, you have to have decision making properly. It has to be on time. And customers are demanding. I remember that if uh, during my time, if I would have talked about net banking when I was a student, I was a college going student or a school going student, then probably nobody would have believed that that is possible because at that time customers were satisfied with branch related internet branch related banking where they go used to go to the branch to withdraw cash. Now if you talk about that I have to take a leave to go to the branch, people will be laughing at you because they say that okay, net banking है, mobile app से आप करवा सकते हो, Google Pay से आप transfer कर सकते हो. Why do you have to go to the bank? So this is what customers are all about now. They are more demanding, and as soon as they are more demanding, there is a lot of issues also which are created which have to be dealt with regarding security issues also. So when I'm talking about big data, I'm also talking about the security aspect because that big data option has to be secure enough. So this is what actually is very important. So taking advantage of the information acquired by companies is a critical success factor. So sorry for the interruption. Actually, I had some call. I just put it in silent mode so that there's no disturbance. Okay. So what type of data are we dealing with? Because a lot of data is available now. Just recently there was a sequence saying that probably lot of damage has been done by the new variant of the virus, and lot of such data was being spread. Some videos was being spread. It included that there was a movie made in the 1963 or 53 on this name, variant. Some movie was made. It was all circulated on the social media, but then ultimately when I did a fact check, I found out that it was not. It was a fake news, and it was not actually, such a movie was not made in 1953 or 63. So whatever data we are dealing with, are the data credible? That's a very important thing. So whenever you are looking at some data, you have to look at some characteristics for the data. First one is the accuracy of the data. Is the data that you are fetching accurate enough or not? Because if the data is not accurate, then the processing would not give the desired results. Similarly, validity. Is it complying with whatever requirements have been laid down or not? Is it consistent over time? So that's very important aspect of data which we are looking at. Reliability. Uh, are they reliable data? Are they collected properly? Are they being saved properly or stored properly? Are manipulations allowed on the data by somebody, unauthorized people? So all this leads to the reliability of data. So reliability is very important. Timelessness is one more important characteristic. It should be relevant for the time that we are looking at. And completeness. So there should not be any missing data, invalid data, or incomplete data. So all these are characteristics of data that you should be having with you, or the data you should be verifying that whether it is matching these characteristics for making it a quality data. So see, this is what actually has turned big data into what it is today. Device explosion. There are a lot of devices available. Earlier, I remember my first mobile when I was in college, rather I just completed college, was Nokia 1100. That was the mobile that was initially being used at that time, and that was trending mobile at that time, right? Now people have more than one person has more than two or three mobiles with them, devices with them, laptops, lot of other wearable devices are there. So there is a huge device explosion, and whenever this device explosion takes place, it is leading to a lot of data. Social networks, that is, we are using a lot of social media platforms. WhatsApp is one of them, LinkedIn. LinkedIn can be productively used also. All the particular networks can be productively used, but then there's a lot of junk also coming in. So this junk data also needs to be separated. So social media has more than 2 billion. This is a conservative estimate. There are many people who are not still included in this list, but they are already using mobiles. They are using social networks. Now, along with this, there's a lot of web traffic because of the connections. Now, this is a 2015 figure, which is very much long back. Due to the lockdown, due to the COVID problem, we have seen a huge increase in the kind of connections that have taken place. Sensor networks are there, which are growing at a rapid pace of more than 10 billion. So there's a huge increase of data that is taking place. Now, compared to that, we are seeing there is a cheap storage. That means what was available at $100 uh, is actually gets 3 million more times storage than 30 years. That means before 30 years, if I would have used the storage, it would have been on more than 3 times or 3 million times of data I can store in current storage device, and the cost has come down, not gone up. So that's a huge benefit for the people who are using it. Inexpensive computing, like computing speed has increased and devices have become more cheaper. So this is what we are looking at. This is fueling the big data challenge. So I would just like to focus upon these tools right now. Difficulties include capture, storage, search, sharing, analysis, and visualization. So these are very important things which are you need to focus upon. It's very difficult to capture the data, store it, search it, share it, analyze it, and visualize it. These are the challenges of big data which we call about. So whenever we have a big data value chain, what we are doing is we are collecting the data. We are now this data can be from different sources, multiple sources. So when they are from multiple sources, you have to again classify them, make them uniform, and then store it, or maybe convert the data into another type and then store it. So collection, ingestion, that means single data store. You need to load vast amount of data into that single data store. Then you need to clean the data. You need to look for missing data, etc., and then integrate it with each other and analyze it and then deliver it based on queries, visualization, or real-time delivery based on the query that has been fired by the customer. So this is standardization requirement at each and every stage, right? It's very difficult. See, I mean, I would not be taking you to the programming front today because I think so that is scheduled for other sessions by other speakers. But when I look at structured, unstructured, and semi-structured data. Structured was taken care of earlier by DBMS and RDBMS packages. But unstructured and semi-structured are some things which, some data which we cannot deal with through our normal database solutions that we have. So we need to look at that from a different angle and we need to process it in a different angle. And then cleaning of data is very important to make it error free, to remove the missing data, to have data which are really credible enough so that we can go ahead with the processing. So these all are very important, and for each and every step we need standardized approaches or standardized tools which can help us in that. So we have a lot of V's here. V for volume, huge volume of data. Variety, we have a lot of variety of data coming in. It is not just same type of data. Velocity, the speed at which the data is generated is tremendous. In 1 second, we can have lot of data being generated. So I'm just taking you a little bit back here from the storage angle and from the type of packages that we use. ERP or CRM was earlier used. I'm not going too much back into the basic DBMS, but I'm just taking you to ERP and customer relationship management systems. So we had payables, contacts, payroll, uh, deal tracking, inventory, sales pipeline. All this were possible through ERP normally, and that used to occupy megabytes of storage. Then came Web 2.0, where we took it to the next level. That means we added advertising, we added mobile to it, we added collaboration. A lot of collaborative packages or platforms are there. We added e-commerce, which resulted in weblogs, digital marketing, search marketing, recommendations all being used. So that increased our usage to terabytes. Now we are going for petabytes and more, where big data is dealing with clickstream, uh, wikis or blogs, sensors, RFID devices. So a lot of devices are generating a lot of data, and that data is in different forms: audio, video data, social sentiment related data, which is leading to all these files being generated: text, image, weather information, e-government feeds. Government has started using a lot of data to good effect using big data. I'll give you one example that in a foreign country, actually, I delivered one of my keynote addresses in West Ukrainian National University, which is located in Ukraine, some months back, and there I was dealing with how big data can actually change the way the financial transactions and financial governance is concerned. So there were a lot of questions from the audience, right? But what I really understood is that across countries, the same problem is there, that people are not paying tax. So how can we locate how software can be useful in it? Then I told them that how big data can be useful and how you can combine it with different technologies to actually integrate the data of one person across different platforms. Social media, suppose if I say that, then there was a question that how do you locate whether a financial transaction has been made if it is not made through the bank? Then one more important criteria was social media data. See, whenever I go abroad, right, I put my pics on social media. Anybody does it, right? Whenever I purchase a new property, there is some housewarming ceremony, and that new property is posted on the social media saying that my new house. If you may not post, your daughter, son, your wife, somebody else may post. So that can be tracked. So not necessarily that your money is directly going into that property, but you have routed it to somebody else. That can also be reflected through your relative tracking, etc. So huge amount of transactions above a particular amount can be tracked very easily with the help of big data analytics software that can be generated. So if I talk about that, if a government, if suppose tomorrow Indian government or income tax department decides that okay, there's a lot of comments going on that only 3% of the public are paying tax, or maybe 10% right now. Other 90% balance 90% is not paying tax. So is it that they are not having taxable income, or is it that there is some other problem that they are evading tax? So that can easily be tracked by tracking all the information of a person sitting in the income tax office. It's very much possible. If there is a willpower, it's very much possible, and that will lead to a lot of recovery of unaccounted income, whether it is from builders, whether it is from politicians, whether it is from common man. All these things are possible. So this is where big data is very useful. Now, some kind of analytics that we are dealing with, social analytics is one of them. Where's the social sentiment? What's the social sentiment of my product? Anyone has actually launched a product, any company, they want to actually evaluate that what is the social sentiment of the product. They can do social analytics to find it out. Live feed data. How can I optimize my services based on patterns of weather, traffic, etc.? So this can be done by most of the companies who are dealing with such related businesses. So live feed data feed is going into their system, and they can actually predict how they can optimize the things. How do I better predict future outcomes? That is advanced analytics. So all this is a part of byproduct of big data which is being generated. This was what I was talking about. Any customer, entire customer की जो भी कुंडली है, you mean if you want to have the full details of a customer. You can easily have it through a single view of the customer if you have a software which can support it, which actually can deal with the social media handles of the customer, banking or finance transactions, uh, history of transactions through SAP and IBM. Suppose if the company wants to know that this particular customer, Mr. X, how many transactions has he contributed to in last 5 years? All the details will be available from the SAP or ERP package that has been installed. All the purchase related information, online purchases, then entertainment related, gaming. So you can just name it and all the information is available very easily, right? Now, when I'm talking about data, let me be very specific regarding this is that never disclose your data to any when you go to any mall or any place where it is unauthorized, because normally what happens with these magic holidays and such holidays, they have people standing there and they fill your data. They are not actually doing the collection of data, they are actually going to sell your data. That means suppose if many times there is a form which they give you that there's a lucky draw, and if you fill this and submit it within 3 days, there's a lucky draw. If you're selected, you will get a 2 night, 3 day package at our resort. Now this data normally don't fill it because this is a dubious related data collection method where the customer is filling some of the, normally what happens is that some people just fill the contact number and name. Some people fill all the details. So depending upon what you have filled, your data will be sold. Suppose if I say that if you're just giving your name and your phone number, then it is 50 paise per record. It is being sold. If you're just giving your phone number, name you're not writing, then 25 paise per record. Now you may think that 25 and 50 paise has no value, but if you just say that how many footfalls are there at a mall, similarly there are many malls which are located. So a person who is dealing with such data is dealing in crores of records. So that makes a huge amount, right? And your privacy is being disturbed. 1 rupee for name, email ID, and phone number. 2 rupees for entire information like what is your income, how many four-wheelers or two-wheelers you're having, where is your house located, address, everything. That covers more than 2 rupees. So all this is being sold. This is the regular selling that is evident to you. But lot of such selling of data is happening behind your back without your information. And these big names that we are looking at, they are doing this. So we need to be very careful about how we are maintaining ourselves in your social media network and public domain. Don't disclose information unless it is required. Now, real-time analytics, what is the decision requirement? See, customer has a certain behavior pattern, customer has a certain spending pattern. So you need to catch hold of that pattern. Just like politicians do. They know that people have some voting pattern. They catch hold of that voting pattern and promise something that is coming within that voting pattern. So here product recommendations that are relevant and compelling, right? Give such offers because you know the customer behavior. Give such offers which may compel and which is relevant to the customer and customer will buy it, right? Learning why customers switch to competitors and their offers in time to counter. Give them some offers because say suppose I am with Tata Sky for the last many years. Now during my last few transactions of which I've been dealing with customer care, I've been talking to customer care. Based on that itself, they can locate whether this customer is satisfied or not. If the customer is not satisfied, that means there are chances that he may go to the competitor. So give us such a scheme or uh, market marketable scheme has to be launched in such a manner that that particular customer will not leave to any other competitor. So that is how these people are using real-time analytics. Friend invitation to join a game or activity that expands business. So this is very important. Ludo has particularly been very popular on this front during lockdown. Preventing fraud as it is occurring and preventing more proactively. That means here fraud, there are a lot of frauds are happening. So how do you safeguard against the fraud? For that also companies have a mechanism that who are the probable targets. So they should be educated regarding it. improving the marketing and effectiveness of a promotion while it is still in play. You have to again see companies are putting a lot of effort into marketing themselves, they're marketing their products, and the promotions, sales promotions that they are occurring, that should be very much effective when they are in play. Otherwise, customers will not be translating into profit for these companies. So they want this to be circulated more and more. More promotion should be given to their product, and that can reach more people. So this is where real time analytic requirements are being managed. Now this was an old model, the top diagram. Few companies are generating data and all others are consuming data, right? That means this companies were generating data and people were consuming data. Now it is that all of us are generating data and all of us are consuming data. So even if I'm sending a WhatsApp message, good morning, with some emoji, etc., I am generating some data. So earlier I was just a consumer, now I am also a generator of data. So data generation has increased considerably. Now this is what we are looking at: business intelligence and predictive analytics and data mining. Now we are going towards more of a predictive phase. Earlier we were into just business intelligence solutions where we have ad hoc querying and reporting. Now it is not like that. It has changed considerably. And optimization and predictive analysis has been center stage. So which are the major players who are taking benefit of it? Major players are Google, Hadoop, MapReduce, Mahout, Apache, and Cassandra. Right now, they have a lot of tools available called NoSQL. NoSQL is where you is now the flavor of the market, and a lot of people have shifted to NoSQL now. MapReduce, storage related, lot of tools are available, servers are available, and processing tools are available. So this is actually changing the way the whole analytic industry is moving. Hadoop, most of you might be aware about this name. It has been there since many years. In India, it is comparatively maybe 5 to 10 years old. In abroad, it has been there for many years. So Apache Hadoop is for big data. It is a set of open source projects that transform commodity hardware into a service that can store data reliably and allow huge distributed computations. So we are dealing with two things here. I want storage also, and that too reliable storage. Second is distributed computations and getting my results. So these two things are done by Hadoop. Key attributes of this is it's open source, uh, highly scalable. You can make it scalable also for small transactions, so it will work. For big transactions also it will work. Runs on commodity hardware. They are redundant and reliable. That is, no data loss takes place. And batch processing is being used. So it is using MapReduce for batch processing. Now traditional RDBMS and Hadoop, what is the difference here? I've just tried to single out the parameters on that. Data size is the first parameter. In traditional RDBMS, it was using gigabytes or terabytes. Here it is, in Hadoop, it is using petabytes, even exabytes. Access was interactive and batch. Here in Hadoop, it is only batch processing. Updates, read or write many times. Here it is just in Hadoop, write once and read many times. Structure was static in traditional. Here it is dynamic schema. And integrity was high. Here integrity is comparatively low. Scaling non-linear. Here it is linear. DBA ratio 1 is to 40. Here it is 1 is to 3000. So huge benefit for companies who have employed Hadoop. Microsoft Azure Insight is also used here, which actually enables big data solutions in the cloud. Now there are a lot of such sub tools also which are available, which can give you much more benefit when you are looking at processing of data. So you can develop it in .NET and Java. There is a HDP platform which is available. 100% Apache Hadoop solutions are there in the cloud, and this has been very much tested and tried. How this is working, just a small overview. As I told you, I'm not going into the technical domain too much. but I'll just take you to the architecture a little bit here. So files are there, they are stored on different servers, and through the coding actually they are runtime queries are being processing of data is done and the queries are satisfied, and ultimately it is giving in a visualization or a pattern format to the client or customer or the stakeholder who wants to use that data. So this is how Hadoop works. I've just included this. This can be useful for some of the people who want to go into Hadoop in a detailed manner. So here I've just identified this into Hadoop ecosystem into five parts rather. Red stands for core Hadoop, where core Hadoop operations are performed. Blue stands for data processing part. Green stands for packages. Purple stands for Microsoft integration points and value additions. And orange stands for data movement. So you can see that we can just classify this entire ecosystem into this category, and then this is what is happening in big data analytics basically. So Hadoop is one example. There are many other applications which are following. So this is a traditional e-commerce data flow. Here there's operational data. If anybody has any queries, they can interrupt in between and ask if you have it, or we can have other question and answer at the last, whatever is your preference. So operational data, we have a lot of data being generated here. Access data, ETL process, extract, transform, load is done. This is the traditional operational data which is worked upon. And we are actually cleaning that data, and after cleaning that data we are storing it in a data warehouse. Again, it can be separated into a data mart. If it is subject oriented data, it can be separated into a data mart, and then data mining can be done on that data. But data warehouse here means that it is that type of data which cannot be updated once it is stored. So you cannot update your data once you have stored the data in the data warehouse. So on that transactions, on that data, actually the mining is done, or the OLAP cube is made and then mining is done. Then the logs are available. Now these logs are also managed. How much? Okay. See, suppose if I say that one company is actually having a TV ad running, it wants to see that how much visibility is there of that TV ad among the audience. Then that can be done through traditional new data flow that we are talking about. In traditional, that was not possible because for traditional, they will have to go through the um, previous records and then they are able to give some kind of decision on this. Here we can have active logs being generated, and then through that lively we can see that how many ads, when the ads are playing, which time is the best for the ad to be played, what is the reach of the ad among the audience, what segment of audience are watching it, and also we can have a graph which is symbolizing which is the particular uh, indication that the ad is profitable to manage during a particular time or not. So that can everything be managed in the new e-commerce big data flow. So there's a difference between old one, traditional one, and new one. This can again be stored in the data warehouse. So Hadoop data flow is somewhat simple. I've tried to simplify it here. Data is there, data is processed through Hadoop, and then analytical softwares give the analytic view of it. So Power Pivot is also one option available. Pentaho is also one option available. It's a BI tool which is used. As I told you that some tools are interactive, that is they are intersecting in both BI as well as it can be used for big data analytics. So this is one of them, Power Pivot. There's a huge amount of data that can be retrieved within a small time. So that is the benefit of such kind of tools. Now we go to the actual use cases. I have discussed already some of the use cases. I'll go through all these use cases also. This is a recommendation. This is an expert recommendation that you're getting. If you buy a book, you get a recommendation. Now there you're using a lot of other technology also along with big data visualization, big data analytics, right? So this is one application of it where we are giving some recommendation based on the previous purchases or based on the spending habits. Social network analysis in enterprise for productivity. So this is a huge social media network which is being highlighted. It's a major source of income for most of the people who are dealing with data here. So lot of analytics can be done over here, and you can really find out links between people, links between products, links between some kind of companies. Everything can be tracked, link among products, everything can be tracked using this particular big data analytics softwares. Personalized recommendation for you, a particular scheme is recommended, a particular book is recommended, so that's a personalized recommendation which we are looking at. Then you have customer behavior sequence analytics. Like there was a case wherein in UK, actually there was one lady who was standing. The IBM has tried this experiment and they have succeeded in that. There was an old lady who was trying to buy some toy, through her mobile. Immediately when she tried to open an app and go into the details and try to search for the product, the image was captured of that lady and that was sent to the nearby executives who were there in the nearby locations. They were tracking this lady's social networks. Very soon, within a few minutes, 1 minute actually, all the social media transactions also were obtained by these people. They were trying to monitor that who is she buying the toy for? Is it a close relative, or is it her grandson or granddaughter, or is it somebody else who is not related but nearby, living nearby somewhere? So according to that, the toys were shown, the price range was shown, because if it is for her grandson or granddaughter, then obviously she'll be spending more on the product if the product is good. So they showed the product accordingly, and then ultimately her face expressions were also being captured as the product was being seen by her. So this is how things are moving. So this is where analytics is taking a big leap. Customer is now God for most of the companies. They have realized this after 2 years of COVID breakout, where they realized that now customers are the only way how we can come out of this particular economic slowdown. So they are trying to evaluate the customer sequence, behavior sequence, and trying to analyze it and trying to give them a better bargain so that they don't leave them. So this is something which is very much evident. Financial analysis, uh, graph analytics for financial analysis. So this is also very much being managed here. We have a huge source of financial transactions which can be analyzed, and the spending pattern can be judged, and which particular product do they spend upon more, where, what is the reason for that. All this can be known based on the financial analysis of that person also. And lot of packages like you may say term insurance, medical insurance, all this can be sold based on the financial analysis of that individual. Even products like vehicles like car, house, etc., can also be sold based to such people based on the analysis. So right now what happens is that the best example for this would be banks. Banks have a huge data, because when they fill the form, over account opening form, at that time they have all the information about the client. And if the bank wants, every year also the updated details can be received by the bank, because customers would fill in, account holders would fill in the data. So they have all the data. Now if suppose somebody is uh, having two kids, right, then obviously there would be questions that are they having any insurance or not. If they have ticked that no, they don't have any insurance, term insurance or any other insurance, then obviously such policies would be pitched in by the bank itself, because now bank has a tie-up with various such insurance agents. Many of the banks themselves have insurance relation in the sister companies. So this all can be managed properly. So this is how financial analysis is taking place, and through the graph analytics this is very much prevalent. Social media monitoring is also a huge uh, gain, I can say, because lot of companies are taking benefit of this social media monitoring also, and they are pitching their products in such a manner that the selling is increasing. It can also be used for counseling now. I would just like to give one more example that during this lockdown phase and during the online sessions, we faced a lot of problems in the students. Not only our university, but a lot of other universities also reported this, that they faced a lot of problems as far as students' mental health was concerned. By mental health, what I mean is the mental well-being. They were disturbed, they were under stress, they were not happy staying at home, so they need some outgo. So if they are spending, if the media, social media is also being monitored, what is the status they are keeping, what are the pics they are sharing, all this would indicate a certain trend. That indicate that trend can also be judged, because a lot of suicide cases can be avoided if they are found out on time. So this can be a very good example of where we can use big data for. Now, a lot of such products are being sold. A lot of campaignings are being done with the help of customer social analysis. Now here social media of the customer is there, analyzed, and also such people are targeted who have a huge following. Suppose if somebody is a union leader of some particular group, or somebody is some caste based leader of a particular community, then they can influence other people. So that kind of a, the indirect analysis also being done for pitching different products and different uh, companies. Data exploration is a huge. I mean, there are a lot of challenges here, but then still data exploration is going on in a big way in India and abroad also. As I told you, graph analytics and visualization, it's a huge. Uh, just I've given this example where a graph is being matched, and according to that, actually, we are working on a lot of projects in this area. So I would not like to disclose my projects right now, but I'm just, if you want to identify a particular, based on a picture, you want to identify that particular person. It is possible using data analytics and visualization, combine it with AI. So that's very much possible. Visualization for navigation and exploration. So a lot of navigation and exploration is going on, and that visualization is also very important. I want to trace the information diffusion from where that information has gone into social media, because right now lot of uh, fake news is doing the rounds. Social media is the nearest possible way on how we can leak the data into illegal data into social media. So if suppose somebody is forwarding a tweet, or somebody is forwarding a message on WhatsApp, it's a video, right? It may be saying anything about any particular community, right? It may lead to a lot of problems as far as communal tensions are concerned. Now, it's very important to trace from where this information has come, who has spread this information, and how did that person receive the information. So that is easily done with the help of such kind of tools. Graph search, this is a huge topic for research right now going on, and people are doing on knowledge management, and graph engines are very much the taste right now in research that is going on. Security related, also lot of concerns are there. I've already named some of the security related challenges. One is hacking, different attacks going on in, so on the devices. Other than that, Ponzi scheme detection, that is also very much going on right now, and now people are trying to um, fool on the net. A lot of such mechanisms are being floated out, where they ask for your, they ask you to click on a link to update your details, and then your details are shared on that link by you, and then that is being used by such criminals. So these are all attacks that can be prevented if you have a proper analytics in place, because it will ask you for a region. Just like I would give you an example that I was using my credit card for a particular transaction when I was in Northeast during Diwali before, in 2019. When I was using the credit card, immediately I got a call before approving of that credit card transaction that I did. I got a call from the customer relationship manager of that particular credit card department, saying that you have used, sir, are you really in Northeast right now, because you have used a card which you have never gone there before. So they are doing all the location mapping also, and that is actually adding to the security features. So a lot of such security related features are possible. Anomaly detection is very much required. You want abnormal behaviors in organization. You want to track certain individuals who are behaving in a different manner. So that can be there. You can have outlier detection also possible through various sources. So such kind of details can actually decrease threats such as any espionage, sabotage, or colleague shooting, suicide, which can happen. That can be prevented if we can identify such cases in advance. And big data analytics is being used in a big way. Fraud detection for banks also is taking place. Cyber attacks, operation analysis, a lot of network related KPI, time series, and such performance are being monitored here. So operation analysis is also a very big way of going into this. Other planet related visualization is also taking place through big data. You have data through satellites being generated from other planets that is actually analyzed and visualized over here. So that is also possible. Cellular network analysis is also possible. You have a lot of cellular companies who are doing these operations. Monitoring a large cloud, that is also being done through analytics. Data warehouse augmentation is also being done. So a lot of such, I mean, if I go on, it's a huge, I'll come on to this part, smart navigation utilizing real-time road information. This is very much important for smart city traffic management. Now here the problem is that if I'm going on a way where huge traffic is there, then it is obvious that I'm going to be stuck up, and it's going to add to the people's troubles, because the person who is coming behind me also will be stuck behind me in that traffic. So it's better to have such a solution wherein we can analyze and it will give you a solution on which path where you want to go and which is the path where traffic is less. So that can be managed, and this is actually a part of smart navigation, which is utilizing real-time road information, and accordingly it can be done. Same can be used for parking also, parking vehicles. So that can also be used. This is graph analysis for image and video analysis. So this is very much important. This has a lot of significance, not only in making of certain kind of bikes or defining the structure of the bike based on popular sentiment, but also it can be. Uh, just a minute, I just have a glass of water. This can also be used for crime detection, where image processing can be used, and image processing can be used as a part of big data, and those images can be stored and they can be monitored also. So a lot of crimes are happening now. If there is any kind of analytics that is performed on the types of crime, which area, what is the uh, modus operandi of the crime, what is the time duration of the crime, then we can actually come to know a lot of things and we can prevent such crimes from happening. So this is also being used in a big way in crime detection and monitoring. Now, this is especially when we are talking about DNA sequencing and all, genome sequencing is also one of the important parameters where, again, graph matching can be used, and graph matching is a part of big data analytics and visualization. Enterprise related management, data management can be done very effectively with the help of data curation, data monitoring, and data management in a proper manner using big data analytics. Understanding the brain network, a lot of people are trying to understand, scientists are working on this brain network identification, and once that is done, then probably they'll come up with a solution where they can predict what you're thinking at a particular point of time. That would be dangerous, but then that is also on the pipeline. Large scale sky monitoring also can be done, and a lot of data is being generated through that, and that can also tell you about different dangers from space, and what all should be taken care of as far as space related parameters are concerned. Now, this is a e-governance platform which a Indian e-governance platform being used. So this is how the flow is all about. Now, as you see that all the information is passing on to e-district, home department, labor department, food and supply, law department, and from there that data is going to the different operations, starting from core Hadoop to advanced Hadoop, where all the analysis and visualization is being done, and then details are being extracted. So dashboards are there, which will give you entire details, which will give you the analysis, how it is being performed. So this is how we are managing it. Now, what are the sources of spatial big data? These are some of the sources where we are looking at GPS enabled services, satellite remote sensing. This is used in a big manner because a lot of companies who are dealing in space solutions, especially government companies like ISRO, etc., they are working on this. Aerial surveying is also possible. Most of the countries are doing it. Radar, uh, and there can be sensor networks, digital cameras. So a lot of such utilities actually of this so are coming from these sources of spatial data. So it's coming from, where is it coming from actually? The big data is coming from everywhere. It's not particularly limited to any particular place. Connected cars, wearables, connected TVs, Internet of Things, tablets, smartphones, you name it, it's coming from that source. So a lot of data is being generated from this. Now, I'll just like to take a break of 1 or 2 minutes. We can have a small questions answer session if there are any questions, or else I'll continue after 1 or 2 minutes. If there are any questions, I can. Okay, I think I'll proceed. Yeah. Now, actually, where is this big data coming from? It's user generated content. So a lot of us are using devices. Laptops is most common right now. Earlier, I remember that we were using desktops. Now, almost desktops have become extinct, sort of. Most of them are using their laptops. And again, after a few years, maybe instead of laptops, we'll be having just tabs and mobiles, and they are going to generate a huge amount of data. We'll be having wearable watches, etc., which can act as a mobile or a smart way of communication. This data is also coming from sensors, right? Now, sensors are a huge amount of data creation which are taking place. If you go to a mall also, you have lot of sensors at various places, starting from the opening of the door to various other applications. So whatever advanced technology we are using, every technology is using sensors to a certain degree, that is generating a huge amount of data. It's used in agriculture also. Sensors are used for various agriculture related applications, and we can see the efficiency from that. It's coming from all these smart things like PCs, tablets, smartphones, connected TVs, connected cars, wearables, and where we are going, things like smart homes, smart cities, smart offices, smart factories. So all this is generating this kind of big data. I've already talked about this. There are four V's which we have already talked about: volume, variety, veracity, that is uncertainty of data, because there's a lot of, you don't know what the next type of data would be. It would be structured, unstructured, so there's a lot of uncertainty. Velocity, analysis of streaming data, the velocity is, the speed is huge. But also one important thing is a 5V, which is called value. For real-time spatial big data, decisions can be to enhance through visualization of dynamic change like climate, traffic, social media-based attitudes, and massive inventory locations. So it is creating value for the company which is using that. So that is a fifth V which has been added over here. Now, earlier what it was and now what the data set looks like is quite different. Type of data is unstructured right now, 100 terabytes. I've already talked about some of these aspects. Analytical methods in big data are mainly machine learning. Earlier it was hypothesis based. Primary purpose is database products, and here it was in traditional analytics, it was internal decision support and services. So these 5 V's are going to change the way the entire transactions are taking place. Now, these are the four types of analytics which are being used: descriptive, diagnostic, predictive, and prospective. Right? What should I do? What will happen? Why did it happen? And what happened? Descriptive is what happened. Right? Try to analyze what happens and what is the reason for that. Diagnostic is why did it happen? So what happened is in descriptive. We go to the event. Diagnostic is why did it happen? What was the reason for that? So you use business intelligence, sensitivity analysis, design of experiments, etc. to know that. Predictive is what will happen. Now people want this more. Right? Earlier people used to be content with what happened and why did it happen. Now they want to know what will happen in the future. So there you have linear and logistic regression, neural networks, and support vector machines. Perspective is the fourth one. What should I do? Right? So that can give me better profit. So simulation is required. So simulation, optimization, so linear, non-linear programming. So all this actually is taking place. Now here, analytical sophistication is low in descriptive. Diagnostic is, it's a little bit better. Predictive, it is quite larger, and in perspective it is quite high. So here analytical specific sophistication is high, so there may be more uh, type of tools required for this, more type of focus on skills and different other parameters is required in this particular perspective analytics compared to descriptive analytics. So this is what I was talking about. Normally we go from this particular or in this particular order, that you have value creation taking place when you go up the ladder, right? Always it is said that difficulty is also more and value addition is also more. So in descriptive analysis analytics, what happens is that we try to figure out what happened. So in that, difficulty is also less and value that you'll be getting from that data is also less. Diagnostic analysis, difficulty is more, a little bit more than descriptive, and value is also more. Predictive difficulty is higher than diagnostic and descriptive, and value is also more. Value means value generated from that data that will be profitable for the company. And prospective analysis is where how can we make it happen. That difficulty is quite large, highest, and value is also highest. So these analytical models will give you an idea how you should be proceeding, which model to use based on your requirement. Mostly now companies are preferring prospective analytics for that. So as I told you, This is a little bit more depth about descriptive analytics, reporting or online analytical processing, OLAP, which we call, right? So this is a part of, we can have dashboards, data visualization, which have been used, and these are core of traditional business intelligence. So you can say descriptive analysis is using more of a BI tools as such. So here data visualization, you can have graphs, you can have dashboard through which, or tables through which you can depict it. Then comes predictive analytics. Here we have algorithms for predictive analytics such as regression analysis, machine learning, and neural networks, which have been around for some time, and this is a huge change coming up slowly. So marketing normally is the most important part or target of any predictive analytic applications, whereas descriptive analytics will help, that output will help in predictive analytics. So that is the input for predictive analytics. Now prospective analytics, as I told you, is advanced analytics, and it is often used for allocation of scarce resources. Suppose if you have some resource which you have very limited, we use linear programming for that. Basically, we want to allocate resources and the resources are limited. There are constraints on the use of resources. And how do you optimize it? So for that, you need to allocate it in such a manner that your resources are best occupied and lying idle for the less time. So that is basically what optimization is all about. And this perspective analytics can help in optimization of that. We can use this also for, just like we saw this during COVID situation, so especially second wave. Hospitals were not having beds. People were not knowing about where to go, which hospital to go, which hospital has ICU right now free, which hospital oxygen is available. So all this can be done properly with the help of prescriptive analytics, where you know how many resources you're having and how to allocate it. So that can be one game changer here. Now this was used earlier also. I mean, it's not that it was used long back earlier, or it is now being planned right now. But we just, if we go back in history, in September 84, 1854, I've just taken this from one of the sites that I liked it, so I've just taken this slide from there. Now this person actually is called the father of public health, Dr. Snow, and he observed cholera firsthand in 1831 as he was a surgeon, and then he started visualizing how to counter this because this was a disease which was spreading. So he made a map. Cholera deaths are in black. He made a map out of this for England, Soho region, and he tried to figure out which are the locations which have deaths due to cholera. Then slowly he started expanding the region, and then all the locations are circled. Then he came to a particular conclusion that this is the most affected area and how to deal with that area, right? So after that, 160 years after later, so England something look like something like this in 2015, and these are the places where the maximum effect has taken place. So this technology was being used earlier also, and now also it's being used, but now we are going more of a technological based angle rather than just map based angle. So density of location of deaths can be identified now very easily, and then government can use that data to good effect because government wants to know that which is the area where maximum possibility is there. Suppose if I say that in Gujarat, suppose if I say that Ahmedabad has had in between more number of cases, then there were a lot of restrictions imposed in Ahmedabad. But this was based on certain localities. It was not that entire Ahmedabad. Suppose the figure says that okay, 100 people were affected with COVID in a particular day in Ahmedabad, then you lock down entire Ahmedabad. It's not required. You just try to lock down that region from where the origination is there. That means you select that region where maximum people are affected and then just cordon off that area or just keep that area in a kind of a lockdown like situation where people don't move out into other areas. So this is how we are dealing with such a situation. So analytics is very powerful as far as this is concerned. This is the hotspot of deaths they were identified. So application of spatial big data and analytics can be used in smart cities and smart villages. First, it is used in politics. Politics is used in a big manner. Right now, campaign management is going on for most of the political parties. Most of the political parties have their own IT cell. That IT cell and campaign management cell, they integrate themselves together, and they have a particular software which will guide them regarding which area to target and what to target with. Suppose if I am going to a village in UP for campaigning, then I should be using a particular type of headgear or particular type of dress. Also, I should be handling those issues which are more prevalent there. To just observe this, I'm just not taking the names, but our honorable PM, he has a very unique style of approaching different places with different kind of accent. If he is in South, he will be speaking a few sentences in Tamil or Kerala. If it is Kerala, then Malayalam, so that people are attracted, it's catching the people's attention. So this all can be done with the help of analytics, where you are giving yourself an idea regarding what is the region's requirement, and accordingly you are giving that to that particular region. Transportation, again, transportation can be optimized with the help of analytics. Supply chain management, supply chain management also can be done in a huge manner, because right now we saw due to COVID what are the problems. People were not getting oxygen on time. Oxygen was available in some of the places, but they were not able to reach at some other places. So we need to look at supply chain management in a different fashion altogether. Logistics is one of that which needs to be looked at. Public safety is also very important. Health parameters, urban traffic. Urban traffic management is required, as I told you. That's a huge plus point if you're going for analysis of traffic management. Similarly, we have climate related changes, we have emergency management services, healthcare. Healthcare sector is going through a huge transformation, and what I feel is that by 2025 or 26, we may be having a big change in the way the healthcare sector is going to dominate, whether it's government or it's private in India. Because now people are demanding such facilities, and that is government is also thinking over it, because in this 2 years we have faced a lot of challenges in the healthcare sector. We have faced a lot of limitations which we have to remove immediately. Energy and environment, again, very important parameters where a lot of analytics can work. Right, we need to preserve the environment, and we need to create new sources of energy. So that can also be one way where big data analytics can play an important role. Climate science, although we have been able to counter this because a lot of cyclones are being predicted in advance, and based on the total map of that location, we can identify which places are prone to cyclone, which are not, so we can take steps accordingly. And then marketing or advertising, so that is also one of the huge gainers from this analytics. This is the architecture of big data analytics, real-time data access, on-demand streaming, which is possible here. So as I told you that this is the big data. These are the uh, sources of data from which the data is being generated. These are traditional sources. These are cloud applications which are supporting this data. And then the data are operated upon, right? And after all the operations, again, the data is converted into output, on which actually we can have predictive analysis done, statistical analysis done, text analysis, and data mining. So in statistical analysis and data mining, we can use R tool very effectively. R Studio or R tool can be used very effectively. Reporting tools are also there. There are a lot of tools like Pentaho, business intelligence and visualization tools. Then you have a lot of such tools are available. You have data mining tools like Veka, etc., which can also be used. You can have real-time decision management and alerts generated, and then scorecards or dashboards can also be maintained. So this is the entire way of how we are dealing with data, how we are visualizing the data, and how we are changing the way the things are moving. Now, how do we link it directly to the smart cities? So I would like your views also on this. I've already given you a lot of solutions in between. I want you also to contribute to this by maybe asking questions or expressing your views here. Uh, E-governance and citizen services. Now, these are pan-India smart solutions, and this says that first e-governance solution is public information. Public should get the information on time regarding government schemes, regarding different parameters that or different kind of facilities that government is offering to the citizen. Normally, this is done in during election time by the government or by particular parties to spread what schemes they have been giving to the public. But public don't know whether the scheme is available or not. So that needs to be done. Grievance redressal is very important. Grievance redressal, by what I mean is that uh, I have some problem. I file a complaint. I don't get a reply. Now, especially in government offices, this used to happen earlier, before 15 years, 10 years. That if you go to a government office, you have to go with all the papers. If one paper is missing, again you'll have to come back and again you'll have to go, right? So all these things can be done easily. Grievance redressal can be done. If you have any problem with any particular department, you can directly put a mail through it, and you can also give a lot of solutions regarding grievance redressal can be given online, and there's a time bound method for this. So this all can be done, and this can be monitored by the all this data can be monitored by the government um, grievance redressal mechanism cell, which actually can keep a track of how many grievances were received, what is the graph of the solving of those complaints, etc. So this is one way of looking at it, where we can have a solution for this particular problem to be solved. Electronic service delivery. This is also again whatever products or whatever services are being delivered. Like if you want to pay a tax online, then is it possible? If you want to pay water tax online, is it possible? Property tax, is it possible online? So all this is a part of e-service delivery which we are looking at. Citizen engagement. Are the citizens happy? Are they knowing about the different schemes? Are they knowing about what is happening, what government is doing? That's very important. Citizens are the city's ears and eyes, so they need to be informed about all the things that are happening around them. Video crime monitoring can also be a part of this, wherein all the crimes are being monitored, or different footages are being checked, and accordingly visualization is being reaching there. Also, we can integrate it that if there is any kind of uh, aberration, any kind of abnormal situation being created, immediately there are alerts being generated beforehand so that we can take action. Suppose if I say that it happened during one of the Northeast violence cases long back, that there was some attack on some Northeast person in Bangalore or somewhere, I think so. And soon by the evening, actually, the place where hardly 500 people were there at railway station on a normal day, there were 5,000 people on that particular day, and there was a stampede also because Northeast people were trying to flee from Bangalore. So this could have been avoided if there was a mechanism of monitoring how many people are there. If there are 5,000 people, or if there are 500 people are expected on normal basis, and if there are 1,000 people coming in also, there needs to be some kind of mechanism which can calculate, okay, these many people are there, and it needs to report to the certain people who can take action regarding the security purpose. So these are all the issues which we are looking at. Waste management is a very big uh, issue here. Waste management is a very big issue because right now we are looking at energy sources, different energy sources, but right now what waste we are having, we are not recycling them. So most of the problems are that most of the people don't know what to do. So if there is an app designed or a particular website design which can give you the entire solutions through visualization also, all the data. Suppose if I want to give some data regarding the waste in my area, or if anybody wants to set up a waste recycling unit, then the steps should be clear how they can go about it and what they can do. And this can be directly connected with big data analytics and visualization because all the data is available at a particular place, and from that it can be distributed to various people and to all the stakeholders, and then the graphical use also can be highlighted. So waste management, waste to energy and fuel, waste to compost, waste water to be treated, all these things can be monitored with the help of big data analytics and visualization. Water management, this is taking place in most of the cities in India. I think so. Mumbai has taken a lead in this, and a lot of societies are having water meters installed right now. So if your usage is increasing beyond a particular uh, count, suppose if there's a water meter installed in the society, and individually each and every house water maintenance, water usage can be monitored, and if suppose there is any leakage also, that can also be identified and preventive mechanism can be done, and water quality can also be monitored. But then for all this you need some kind of a visualization and some kind of results coming out of the thing. Just the tables will not do. So here big data analytics and visualization can be used very effectively. Smart meters and management, now peak load and non-peak load usage can be built differently. Renewable sources of energy can be installed, but then again we need to look at certain areas where renewable energy can be more productive, some areas where smart meters can be more productive, and that is where the visualization of data is important. So data analytics and visualization can play a very important role there. Urban mobility, as I told you already, smart parking is one solution. Intelligent traffic management, we are looking at how traffic can be managed intelligently so that we are avoiding traffic jams and accidents. And actually a study has been done, this is psychological aspect. A study has been done wherein people living in such cities where it takes them more than 1 or 2 hours to cover 40 kilometers due to traffic actually have found a huge difference in their behavioral levels when they reach home or when they go to office. So both the times the delay is there due to traffic, then it makes them their nature quite irritable, and they are not that much happy with people. Their whole behavior psychology changes when they reach home or when they reach to office. So if there is intelligent traffic management that can meet this problem also. Multimodal transport, there can be different ways of transport which are being adopted, so that can be done easily. And there are telemedicine and teleeducation. This is a very big field which has come up because of COVID. People now don't want to go to the hospital for small things. Earlier they used to go to the doctor in the hospital. Now they don't go. Now they try to avoid it by treatment through telephone or through video conferencing. So there again, an analytics can be used to educate the people regarding how to use this in a proper manner. Incubation or trade facilitation centers. Again, new ideas being generated, new funds being released will lead to new centers which are developed for incubation. So this can also be a game changer, and skill development centers. So these are all pan-India solutions which are required. Now, traffic is a typical example. Smart city challenge is where we are. I'm talking about a smart light. Now, how does a smart light go? Like, where do we install the smart lights? Where do we? What should be the range at which the light should be uh, at the full uh, lighting capacity, and otherwise it should be dim or entirely closed. So that depends upon what is the distance of the vehicle or the person coming from the other end. So it identifies movement, and accordingly it suggests some whether it should be on, off, or in dim mode. So street lights can save a lot of energy if their smart lights are properly maintained. Similarly, vehicles can also be monitored properly with the help of analytics here, because I want to see who are violating. It is possible who are violating the traffic signals. So that is possible. So all this is possible. How many people are wearing masks, that can be seen inside. Just like right now we have earlier we had a traffic signal where a police, there used to be police constables or traffic police people standing there. They used to catch the people who were violating the traffic signal. Then slowly came a challan system where we don't have to actually stop. We are not stopped by anybody, but if we violate that signal, we'll get a love letter at home saying the penalty is this much and you have to pay this much. Now, similarly, I expect this also that for the mask also it will be the same thing. If you're not wearing the mask, the images are being captured. Though again, the problem is that so many vehicles are there, so there will be huge storage required of all the images. So that is going to be painstaking from the point of view of the people who are managing this particular system also. But otherwise, it's a very good system of managing it, and you can really analyze the performance of a person if you want to actually have the details of a vehicle. Now, if that vehicle has violated traffic signals 5 times, then you can even take confiscate the license, or you can make it you can stop that person from driving if it is found on a regular basis. So this all is possible with the help of analytics. These are some of the devices which are generating a lot of data and which will be leading to data analytics in the future. As I told you that there's a coffee maker. It knows when your alarm goes off, immediately the coffee maker starts. Right? There's a smart home or bed alarm clock which actually custom tones turns on the coffee maker. Remote programs are used for that. Refrigerator which reorders groceries as needed and suggests recipes. That means suppose if I say I have a refrigerator which have RFID tags. Now I can reorder groceries. I don't need to order it. It actually reorders it, or it gives me a suggestion that I should be ordering these things because are in shortage. So I don't have to go through all the products to see which to order. So there are a lot of such modifications which are taking place, and a lot of devices are generating a lot of data. How do we deal with that data? That's really important. So these are the things that I was talking about. Now, waste management, I just want to clarify a little bit over here because this is a model which we have been designing. We have made a change in this model, and accordingly, we'll be going through this efficient waste management in smart cities through IoT, Internet of Things. Now, this is the model which we have already existing. We have proposed a modification to that. We have added big data analytics and visualization in a big manner so that the entire images are seen by the people sitting in their offices. What I mean by that is that right now the garbage truck. Now, just visualize this as a 2030 scenario where the garbage truck is not driven by a driver, right? I'm just changing the model a little bit. Just try to visualize it. This is not a driver, but there's no driver here. It's a autonomous vehicle, autonomous garbage truck, right? Here, all the garbage has been separated automatically. There is no manual labor to collect those garbage. Now, how do you decide when the bin is when the particular garbage is to be collected from the garbage cans? Different areas have different. Some areas the garbage can be filled in 1 hour itself. Garbage cans. Some may take 1 day to fill. So, do you have the same route every day? No. So there would be a smart system through analytics which would actually tell the autonomous vehicle where the particular garbage can is 70 or 75% filled or more than that filled, so that it can collect that, and then the route will be decided automatically based on the collection of the garbage in the dustbins, the garbage cans. So this is how we are looking at 2030 probably, right? Instead of cloud, we may be having a new mechanism for storing our data properly, and infrastructure would be details would be shared with all the stakeholders from where, including health and safety authorities, manufacturing plant, different hospitals if required, recycling plant. Everybody would be informed regarding what is the state of the waste and how to go for it. Recycling plant is very important, and that should be combined with over here. So this is what I'm visualizing in 2030. Similarly, smart village, right? Last few slides I'll just go through. Smart villages is where you have different technology, living, resources, village services, tourism, and governance. All these are the important parameters which need to be taken care of. Now, for governance, we can have directly a system wherein I don't have to remember all my things. If I just enter my PAN card number, suppose if in US we have a social security number, if we can make it a PAN card number for all, if I just enter my PAN card number, it will show not only the government people, it will show me also what are the schemes that I can avail of, I am eligible for. Because when my PAN card is entered, all my details are coming in it. So if I am eligible for some government scheme wherein I can get a 2 lakh rebate on a new home, then I should be knowing about it first. Most of the people don't know that what schemes they are eligible for. So governance is a part of that also. So there should be a portal which should suggest this, and I can see my performance as a citizen. How many times I have violated the rules, how many times I have contributed to something productive. Similarly, the technology also, appropriate rural technologies like robotics can be used for teaching also. Then for living also, convenience, lot of facilities are there which needs to be uh, provided. Different resources like natural resources, financial resources, human resources are required. Essential services in a village are required, and tourism can be developed in a big way. In northeast, actually, some villages on the border of Bangladesh, etc., have been developed in such a manner that they really look like a fully Wi-Fi village with all the facilities, yet that natural surroundings. They don't have huge hotels there. They have just homestay available. Now this homestay is of that villagers only who have additional capacity. They give it for homestay, and that can be booked online also. So all the facilities making it a smart village. Yet they are not leaving the traditions. So this is where I think so big data analytics can be a big game changer in the villages. Now, this is what the government is aiming for, Pura, that is providing urban amenities in rural areas. This is what we are visualizing, that villagers would be sitting in the farm or in their office and doing analytics, big data analytics of their farms. These are the areas where IoT can also be used in a big way. Smart education, smart surveillance system, healthcare, dairy, farming, weather and irrigation, and smart buildings. So huge kind of changes coming here. This is where big data can play an important role, because data is wherever sensors. I have included this with IoT, AI basically, because without that you cannot have a collective picture of the technologies, of the kind of use cases. See here, smart analytics is taking place through big data. All this data is there: cow related data, house related data, farm related data, tractor, it's a driverless tractor, tractor related data, hen related data, all the livestock that are there in the farmer's possession, that data should be there. Smart control should be possible. Smart sensoring and monitoring should be possible. Smart analysis and planning. Here, visualization very important. So all this is being done properly through this system. So we are calling it as a smart alternative, where all these devices are being integrated to obtain huge amount of data. This data can be again visualized and analyzed, and then decisions can be taken. This is the data generation and future farms that I was talking about. This is a person, he is not a corporate officer, he is a person sitting in an office, he is a farmer, he is sitting in his particular house or office. He is monitoring the drones, data generated from the drones, agribots, smart tractors, cows, different cows are having RFID tags and they're giving signals here, so that data is being generated. So all the farming data is coming here, and he can make whatever changes he needs in this particular system. So this is what we are looking at in the future. For this, big data analytics and visualization is a game changer. So I would like to end by these words: stay socially connected and maintain physical distancing. And I'm open to any questions or any queries, any suggestions, any ideas regarding how we can use big data, or any examples where you have used big data to good effect and it has been effective for the people.